Here's an introduction to the website of the Minor Planet Center. You can see the URL up at the upper left there. It is just www.minorplanetcenter.net. Pretty easy to remember. Now this is the site you need for information about what's orbiting out there. And I thought I'd go to this site to show you a little bit of an animation of how orbits look. So let's take a look at this, and at the top of the page there's observers, public. Let's consider ourselves to be observers. I'm going to go down here where it says lists and plots and go to minor planets. And here are some of the minor planets that are out there. There's different families of minor planets, the Atens, the Apollos, the Amors, based on what their orbits look like. I'm going to go to the list of the Apollo asteroids. These are the ones that cross Earth's orbit, and these are the minor planets that might be a concern of ours because they do cross our orbit. Let's take a look. I'm going to click on this one, which happens to be called 2016 PR8. That's its temporary designation, hasn't gotten a name yet. I'm going to click on that and we'll see what the orbit looks like. Interactive orbit sketch. And here is the orbit. If I hold down the left mouse button and scroll around, you can see what the orbit looks like. Let's go down to the bottom of the page here to see some of the other things we can change here. We can change the zoom. Alright, I'm going to pick the zoom about there because when I go back up, we can see the orbit a little bit more clearly. Here are the orbits of the other planets: Mercury, Venus, there's Earth, the light blue one, that's the orbit of Mars, here's the orbit of Jupiter. So I see that this particular asteroid orbits such that it gets a little bit about as far out as Jupiter. But then when I tilt the orbit, you can see what its tilt looks like. It's tilted by, maybe 15 degrees above the plane of the ecliptic or so. Do you notice that part of the orbit is orange and part of the orbit is blue? The blue part of the orbit is the part that's underneath, that's below the ecliptic, on the south side of the ecliptic, if you will. And then the line of nodes, talk about that, goes from here through the sun to the other side. The argument of the ascending node is the angle from the direction of the vernal equinox, which is not shown here unfortunately, out to where it goes above the plane of the orbit. So that's where that angle comes in. We also talked about the inclination of the orbit, which I said I guess is about 15 degrees here. The argument of the perihelion shows you how far around the orbit the perihelion is. Here's the perihelion right there. We can see this particular object crosses closer to the sun than Earth, which doesn't necessarily mean that it's going to hit the Earth, right? Because if I tilt the orbit right, you can see that when it's closest to the sun, it's underneath, it's below the orbit of Earth. So does this particular asteroid have any impact hazard? Not really. There are other things you can do to play with this particular animation here, and there's lots of different asteroids that you can look at. I invite you to go to the Minor Planet Center homepage and investigate there. You'll find out quite a bit about orbits.